Hello students, welcome to Alpha Educates. So this is your first video of the chapter 13, that is limits and derivatives. So actually this is the introduction of your very important part, that is calculus, and you will be learning calculus in your first year, second year, and if you want to study or if you want to pursue BSc mathematics and on, so you will get the applications of calculus and everything throughout your mathematics career. So this is actually the most essential part of your mathematics. So in this chapter, what shall we learn is that we shall learn how to find limits of a function and how to do derivatives. Okay, so basically in this video we shall learn about what are limits. So from the word limit, what do you understand? Actually, when we say limit, we understand a boundary, isn't it? By the word limit, we understand a boundary or a restriction or a target, you can say. That means since we are dealing with all the real numbers, so our real number will go to some point. Okay, so using those limits we shall define our function, or we shall see the behavior of our function depending on the limits. So before going to the limits, let us see an example. What shall we learn is that, for example, let me take a plane, a flight, say, yeah, my drawing is not so good. So say this is a flight and it is moving from Delhi to Dimapur. Okay, so it started from Delhi at around 10 AM and it reached Dimapur at 2 PM. Fine. So let us see what is the concept. So when the plane was at this point, when the plane was here at this point, the time was 10 AM and what was the distance covered? It was 0 at this point. When the flight was here, then the time, it might be like, if the velocity is average, if the velocity is same throughout, then at the middle point it might be 12 PM, and at this point it might have covered half of the distance. So actually it might not be half, but I am just taking as I'm assuming that it will be half. And when it is 2 PM, then what is happening? It has covered the complete distance, that is whatever distance it is, like maybe 3000 kilometers or 4000 kilometers. So it will have covered the 4000 kilometer within this time interval. Okay, now what can we see from here? As the flight is approaching nearer to 2 PM, that is, as the time is approaching nearer to 2 PM, the distance between the flight and Dimapur, let it be D, it is getting reduced, isn't it? Since when the flight was here, the distance was 4000 kilometers, say. When the flight was here, it was 2000 kilometers. When the flight has reached Dimapur, the distance will be 0. So when the time is tending towards 2, or when the time is approaching 2 PM, the distance is approaching to 0. So in other words, we can say that let me write it here. In other words, we can say that when t is tending to 2, the distance function, the distance is tending to 0, that means the limit of this function will be equal to 0. So this is the concept of limit. Okay, so in limit, basically we are interested about this tending thing, that is t tends to 2, x tends to 0 and such thing. So what is this actually, this tending thing? Let us see about that. So when I write x tends to c, what does it mean? It means that x is nearing to c, but x is not equal to c. Okay, like if I replace the c by 2, so in this case, if x is tending to 2, then x is not equal to 2. But what does this mean? This means that the value of x might be 1.99, or we can take 1.999 or 1.9999. that means the most nearer thing to 2. Similarly, we can take the values x equal to 2.0001, 2.001, 2.01 and so on, but not 2. In both the cases we did not take 2, isn't it? So this is the concept of tending. So in other words, I can say that if x tends to c, then the difference of, or the distance of x and c will always be less than epsilon. And what is this epsilon? It's a very small quantity, a very small quantity, or a very small real number. Like whatever thing you take, whatever the lowest you can imagine, like I have ended it here at 1.99, you can go up to 1.9999 and so on, you can go, but we shall not reach 2. Okay, that is x is tending to 2. And if I subtract, that is, if what is x now, our c was 2, isn't it? So if I take the modulus of 1.999999 and so on minus 2, so what will be that equal to? This will be equal to 0.0000 something 1, and I can write that is less than 0.0000. I can just increase one more 0 and 1, isn't it? So whatever the value of this modulus may be, I can always find a more smaller number or more smaller real number than the difference of these two. Okay, so this is the concept of x is tending to a real number. Now, since in our chapter or in our mathematics in grade 11 mathematics, till now we are dealing with the concept of real numbers. So before going to the real numbers, we shall see that what is the real number line. This is the real number line you have got in your grade 9. So it starts from 0, 1, 2, 3, 4. Actually it's the number line. So -1, -2, -3, -4 and so on. And between that, between 0, 1 there will be half. Between here 1 and 2 there will be 3/2 and so on. And between these two also there will be many more numbers. So this is actually the real number line. Now since we are dealing with real number line, let us take the example of the previous one. That is, we have taken that the flight it started from Delhi and it reached Dimapur. It reached Dimapur at 2 p.m. It started from Delhi at 10 a.m. Okay. Now here we had the initial time. That is, it will start at 10 a.m. and our destination was 2 p.m. Okay, but in case of real numbers, when we say x is tending to c or x is tending to 2 or any real number, then we do not have the starting time. Okay, that means we do not know from where x is starting, but our target is to, our limit is to go to 2. Okay, so since we do not have any starting point, like it will come from the left hand side or right hand side, we do not know. So we shall say that it is approaching from both sides. Like if our limit is 2, if we want to find the limit at the point 2, then we shall take both the cases, that x will tend from the left hand side as well as x will come from the right hand side. So if we want to find a function limit of a function at the point 2, then what are the possibilities of 2 if x is tending to 2? It will either be the point 1.9, 1.99, 1.999 and so on. That is, it is tending from the left hand side, from this side. Okay, if this is our 2, then it is coming from this side. And again, since x is tending to 2, so one more option what we have is 2.0001, 2.001, 2.01 and so on. That is, it is coming from the right side, because after 2 we have 2.00001, whatever number may be, but not 2. Okay, so there are two cases arises, that is, one is approaching from the left hand side and another is approaching from the right hand side. Okay, so since our x tends from both the sides, so accordingly we have two limits. One is called left hand limit, and The another is called right hand limit. Fine. Now what is left hand limit and right hand limit? Okay, so to define left hand limit, at first we need a function and we need a constant, say c. We need a function f of x and we need a constant c. Okay, now the left hand limit will be defined by limit x tends to c f of x, where c is a constant. Now how shall we denote that it is the left hand limit? Because in case of right hand limit also it will be same, limit x tends to c f of x, both the things will be same. Here also the function will be f of x, the limit will be c, because from both the sides we shall tend to c. Okay, now since it is approaching to c, what we want to see the behavior of the function f of x, like whether the limit of this function is also tending towards the same limit or not. Okay, now see, this is our limit and we shall write it as L. Also in this case we can write it as M. Just for our sake of understanding, we are taking two different variables. Okay, now how shall we understand that this is the left hand limit? For this, just write a negative sign above the c in the superfix of c, and here in case of right hand limit just give a positive sign in the superfix in the of the right hand of the c. Okay, now these are the two cases. So since we have got the left hand limit and the right hand limit of a particular function at two same points depending on the left hand side and right hand side, and accordingly we might get two different values. Okay, now our thing is that if we want to say that the function, the limit of the function exists, like if we want to say that limit of the function exists, then what must have? Then this left hand limit must be equal to the right hand limit. That is the condition, sorry, right hand limit. That is, these two must be same, that is L must be equal to M. Only then we can say that the left hand limit and the right hand limit are same. So we shall see a few examples from this, like let us see one example. Let f of x is equal to 1 when x is greater than equal to 0 and 2 when x is less than 0. Okay, now let us draw the graph of this. This is our x, y. So when x is greater than 0, that means x is considering all the points starting from this point. When x is greater than 0, what is the value we will get for y is equal to 1? That means if this is our 1, 2, so this will be 1. So x will consider all these points starting from this. For x equal to 0 we have 1, for x equal to 1 we have 1, x equal to 2 we have 1. So for all the values of x greater than equal to 0 we shall have 1. So our graph will be like this. And for this condition, when x is less than 0, that means we shall not consider this point, so skip this part because we have already taken the point 0 in this function. Now here what is happening, that for x less than 0 we are getting 2. So whatever point we have for x equal to minus 1, minus 2, we shall get this point. So our function, this function will look like this. Now let us check the left hand limit and right hand limit of this function. What will be the left hand limit? The left hand limit will be limit x tends to, so we shall check the point, the function at the point 0. So when x is, if it is negative, so it will be 0 superfix minus 0 negative, so f of x, and that will be equal to what? Now since x is less than 0, so f of x, the value of f of x will be 2, this one. And for the right hand limit, it will be limit x tends to 0 positive. Now for when 0 is greater than or 0 is positive, at that time we need to consider the function this. So our f of x, so this limit will be equal to 1. Now clearly in this function we see that the left hand limit and the right hand limit both are not equal. So in this case we say that the limit of the function does not exist. Okay, so if a limit of the function exists, it must be always equal or it must be unique. Okay, that is the left hand limit and the right hand limit must be always equal. Okay, now let us see an illustration. We have taken a function f of x is equal to x square minus 4 divided by x minus 2, where x cannot be equal to 2. Why x is not equal to 2? Because if x is equal to 2, then this function will not be defined. Okay, this will be something by 0. Now, before going to this problem, one thing we want to see that why we are studying the limits. See, we have got functions like f of x is equal to x plus 3. We have got functions like f of x is equal to x squared. So in such type of functions, these functions are always defined in the real number system. Okay, but if you see this function, like if I want to check the function at x is equal to 2, how will it be? If you put 2 here, so 2 square will be 4, 4 minus 4 will be 0, here 2 minus 2 will be 0. So this is of the form 0 by 0, isn't it? And these types of functions are called, or this type of forms are called indeterminate forms. Indeterminate forms. Like this type of forms are not found yet, or we do not know the exact value of this type of functions. Okay, now since this function is not defined at the point 2, so what might be our another question? Okay, say x is not defined at 2, so let us see what can be the value of the function near 2. Okay, at those times we use the limit. Now what is indeterminate form? Because we know that 0 by any number is 0 is equal to 0 and x by 0 any number is infinity or undefined. Similarly, what will be 0 by 0? You can ask that it might be 0 because 0 by anything is 0. Also you may ask that 0 by anything by 0 is undefined. Also you may say that I can cancel out 0, 0, 1. So we do not have any specific value for this. So these are called indeterminate forms. Now let us check the limiting case for this function. We shall do it analytically. Now we want to check this at the point 2. So what to do in such a case? Let us see. X minus, we can write it x minus 2 x plus 2 divided by x minus 2. So cancelling out, we shall get x plus 2, isn't it? Now this function is defined, and in such a case what to do? Let us see an illustration. Like I shall put the values individually. If this is our table x and f of x. Now in case of x, we want to check the limiting value at the point 2. So let us take the old parts or the points in the left hand side. So at first let us take 1.9, then 1.99, 1.999, 1.9999 and so on. So we shall not take the point 2, and next we have 2, then 2.0001, 2.001, 2.01, 2.1 and so on. Okay, so see that we are always taking the point very near to 2, in the neighborhood of 2. Okay, so corresponding to all these points, what we are getting is in place of 1.9. so if you put here x equal to 1.9, so you shall get 3.9. here you shall get 3.99, 3.999, 3.9999, and we are not worried about this function. This part we are not worried about, so just remove this. Then here 4.0001, 4.001, 4.01 and 4.1. Now what do you see here? As the x is tending towards 2, see 1.9, 1.99, 999, again 9999, so it is tending towards 2, isn't it? Similarly in the right hand side, 2.1, 2.01, 2.00, it is slightly decreasing and tending towards 2. So when x is tending towards 2, how does our function is behaving, or how does our function behaves? So here we see that earlier we had 3.9, then 3.99, 3.999, 3.9999, so it is nearing towards 4, isn't it? Similarly, if we take the right hand limit or right hand case, so it is decreasing towards 4. So we can say that as our x tends towards 2, our function f of x tends towards 4, or from here we can write as x tends towards 2, f of x tends to 4, or we can write limit of x tends to 2, f of x is equal to 4. Fine. Now this is how we find the things. So I have one more example. Now let us see this function. Here we have f of x is equal to x plus 2, where x is not equal to 1, and 0 when x is equal to 1. So we want to find the limit of this function when x tends to 1, f of x. So when x is equal to 1, at that time we have 0, isn't it? That is, we can here write f of 1 is 0. But when x is not equal to 1, at that time what to do? At that time we shall find the limiting value. Okay. Now when x is not equal to 1, this means that if I draw the number line, here we have 0, 1, 2. So when x is not equal to 1, that means we cannot take this value only. Apart from this value, we can take any value less than 1, and we can take any value greater than 1. Okay. So, and also consider that whenever for finding the limiting values, always consider a small neighborhood. Don't take that if it is 1, do not take like -5, 3 or 4, or don't take the points very far. Let's take very near to that particular point. Okay, because the limiting value changes depending on the intervals also. So we must always consider a small neighborhood. Okay. Now, since this point is not defined at the point x equal to 1 or x equal to x not equal to 1, this is x plus 2. So we shall see that we shall consider the points x less than 1 and greater than 1. So let us find the left hand limit. LHL is our limit x tends to 1 negative f of x. So what will be that equal to? So if I draw, or if I plot the graph, let us take this is our x, this is f of x. Now we have a point here 1.01, 1.001, fine. Then and here let us take so will be 0.9, 0.0009, 0.009, and let us take this point 1.001, 1.01, 1.1, and so on. So corresponding to 0.9, if I add it with 2, it will be 2.9, and here it will be 2.09, 2.009, and this part it will be 3.001, 3.01, 3.1. Fine. So in both the cases we see that as x is approaching towards 1, our f of x is approaching towards 3, isn't it? So in the left hand side, if we take the left hand limit, so it will be equal to 3, and also in the right hand limit it will be x tends to 1 positive f of x. So here also it is tending to 3. Okay. So since both this left hand limit and the right hand limit are equal, so we can say that the limit of the function exists. Okay. Fine. So this is another illustration, and now let us go to the algebra of limits. So what are algebra of limits? Algebra of limits. So we need two functions. Say we have a function f of x and we have another function g of x, and let us say the limit of the function x tends to a, f of x, and limit of the function limit x tends to a, g of x exist. So the first condition is that these two limits must exist. If they exist, then we can say then we can find the algebra of this, or then we can find the addition multiplication properties. So if they exist, what we have, number 1, limit of x tends to a, f of x plus g of x will be equal to limit x tends to a, f of x plus limit x tends to a, g of x. Also this is true in case of negative, in case of subtraction. Okay, so number 2 we have limit x tends to a, f of x into g of x. You can check this out. There are many problems in your exercise, also in the examples. You can check this, that whether this is true or not. You can put any function there and then you can see whether these two parts are same or not. Limit x tends to a, f of x, g of x. So this will give us limit x tends to a, f of x into limit x tends to a, g of x. Now to the corollary to this problem, or to a note to this identity, we have, if our f of x is equal to some identity, some constant, say lambda, then what will happen? Limit of x tends to a, lambda of gx will be equal to lambda into limit of x tends to a, g of x. So this is our constant. Okay, and number 3 we have limit x tends to a, that is a division property or quotient. So here we shall have f of x divided by g of x. So in this case what to do? This will be equal to limit f of x, x tends to a, by limit g of x, x tends to a. And what is the condition? They must satisfy g of x cannot be 0 here. Okay, if g of x is equal to 0, then this will be undefined, isn't it? Okay, so this is all about the algebra of limits. And next we shall see the limits of polynomials and rational functions. So next we have polynomial and rational functions, and we shall see how to find their limits. So what is a polynomial function basically? We have seen in the chapter 2 that a polynomial function is written as f of x is equal to a0 plus a1x plus a2x square and so on, an x to the power n, where an is not equal to 0. So this is a polynomial of degree n. Now how to find the limit of this polynomial? So to find the limit of this polynomial, just take limit, let us say x tends to c, and we have f of x. Okay, so write limit on the right hand side as well. So this will be x tends to c along with a0 plus a1x plus a2x square and so on plus an x to the power n. Okay, now using the algebra of limit, that is, if we have two functions fx plus gx, then limit of that will be limit of fx plus limit of gx. And since all these terms are individually functions, so we can distribute it. We can write limit x tends to c a0 plus limit x tends to c a1x plus limit x tends to c a2x square and so on, and finally limit x tends to c an x to the power n. Okay, and this can be written as, now since a0 is a constant, so limit of, we do not have any x here, so we cannot operate the limit, so it will be a0 only. And here we shall have, since a1 is a scalar or a constant, so we can bring the a1 here, and limit of x tends to c x plus bring the a2 here, limit of x tends to c x square plus and so on, an limit of x tends to c x to the power n. So this will give us a0 plus a1 into, since limit x tends to c, so in place of x put c, plus a2 limit of x square, so here will be c square plus so on a1, and in place of x we shall replace it by c to the power n. So what is this? Earlier we had the function a0 a1x plus a2x square plus an x to the power n, and now we are getting a0 plus a1c plus a2c square plus dot 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 a n c to the power n. So in place of x we have now c. So what is this equal to? This is equal to f of c. So that's what we have got. Limit of f of x when x tends to c is equal to f of c. So this is how we find the limit of a polynomial function. So this is quite easy. We shall see some examples in the exercise. And next we have rational functions. How to find the limit of rational functions. So that is quite easy. Limit of rational functions. So how to find it? Let us say f of x is a function which can be written as f of x equal to hx divided by gx. Now if I want to take the limit of this, limit x tends to c, f of x is equal to, it will be limit x tends to c hx divided by gx. And using algebra of limits, this can be written as how? Limit x tends to c hx divided by limit x tends to c gx. So that is all about the limit of a rational function, and the condition is that gx cannot be 0. Okay. So now a question arises is that since gx is not equal to 0, okay, the question arises that whether hx is 0 or not. If hx is 0 and gx is 0, then what to do? See, if our g of x is 0, then two conditions arise. Number one, if hx is 0 or not. If hx is not 0, then we can say that the limit does not exist. That is, this is 0 but this is not 0, so limit does not exist. And if this is 0 but hx is also 0, that is numerator and denominator both are 0, then what to do? At that point we need to simplify these two functions hx and gx, and we shall write like hx will be some h of x we can write in terms of say p of x into rx, and we shall write g of x in terms of p of x into some say qx. So we shall cancel out the p of x and r of x, and then we shall see that this rx and qx, they are not in the 0 by 0 form, and then that will be defined, okay, or they are not both, they are not 0, and then we can define them. So this is how we find the limit of a rational function, and this will be the end of this video. And in the next video we shall come up with a few theorems and our exercise 13.1, and there we shall see all the examples related to these functions, that is polynomial, rational, and whatever we have discussed so far. So that will be the end. Thank you.